This video corresponds with section 5B.5, and this will walk you through the steps as to how to construct the tangent of a circle given the center and a point on the circle. These examples will be found on page 9 of your note packet. Now, you'll notice one of the things that I've done is I've changed one of the directions and one of the keywords in the instructions at the top of page 9, so I'll highlight that as we get through that in a second. So, here in both examples you'll see on the page, I'm only going to work through the first one because it's the same idea for both. I give you a circle, I give you the center, and I've just picked a random arbitrary point on the circle. What we're going to do is we're going to find something called a tangent. Now this is something we're going to talk about a lot more in the second semester, but what a tangent is it's a line that just grazes the circumference of a circle. It grazes it and touches it at exactly one point. Now, we'll talk more, again, why that line is useful, but here we're going to take a look at how do we go about constructing it. So, if you look at your 3 steps here, so the first step is to draw a line from the center through the point that I give you on the circle. So, we're going to go ahead, again, line up your straight edge. From the center, go through your point. Now, again, it doesn't maybe necessarily need to be as long as mine, but it needs to be long enough that it does go through. You'll see why in a second. Now, the second step originally said construct a perpendicular bisector. While that will work, I find that it might be easier to construct an angle bisector. So this is going to be something similar that we've done several other times already throughout this unit. Now, you'll notice you have yourself a long straight line, which again is a straight angle. It's 180 degrees. If we construct the angle bisector, we're still going to end up with something perpendicular, which is the ultimate goal of this in the first place. So to figure that out, treat that point on the circle like the vertex of this straight angle. Go ahead, line up your compass. Now you notice there's not a lot of line here as you go towards the center, so you don't need your compass to be very wide. Okay, you're going to go ahead and draw yourself an arc. Just like so. So again, just like every other angle bisector problem, it has to cross through both sides of the angle. Treat this as your left and your right side. Now, from here, we go ahead and do the same steps we've done before. We go ahead and we're going to go put our compass on where the arc and the line cross. And we go ahead and make one arc. Flip it over. Do it from where the arc and the line cross on the other side. Make a second arc. You'll have your X. What you're going to want to do is line up your ruler with the X and the point that's already on the circle. And you're going to go ahead and draw a straight line through it. If you do this correctly, now there's no physical way to tell if it's only grazing the circle at exactly one singular point, but that is what a tangent does do theoretically. However, if you get it to look like what I've got here in this video, where it's going through the point, goes to the X, and it's just grazing the circle, you have constructed the tangent correctly. So I'm going to go ahead and label it as such. So, to recap, start from the center, draw a line going from the center through whatever point I give you on the circle, extend it, make an angle bisector. So you're going to make an arc that goes through both sides of the angle, again, with your compass at the vertex. Make your 2 little arcs and put a line from the point through where the arcs intersect, and that line will act as a tangent.